Hello and welcome everyone to CyVerse's webinar series. I'm Tina Lee, CyVerse's User Engagement Officer. We are pleased today to bring you our webinar on how to have a conversation with your data using large language models, Jetstream2 cloud resources, and tools in CyVerse. This webinar demonstrates the best of what can be achieved through teamwork, collaboration, open source resources, and of course, just a plain lot of hard work. So first, let's cover some light housekeeping, and then I'll turn things over to our presenters. Today's webinar is about 45 minutes long with time at the end for your questions. Please open the Zoom chat window, type your questions there for the presenters to address after their presentation. If it's a small enough group, we can always unmute and ask questions directly too. As always, we record these webinars and I will post the video recording on the CyVerse YouTube channel. I am now pleased to introduce my colleagues, Nirav Merchant, Mithun Paul, and Tyson Swetnam. Nirav is the director of the University of Arizona's Data Science Institute and PI of CyVerse. Mithun is a research data scientist and educator at the Data Science Institute. And Tyson Swetnam is director of open science at the U of A's Institute for Computational and Data-Enabled Insights. Edwin Skidmore, CyVerse's Director of Infrastructure and leader of our Cloud Native team, has also provided some key parts to today's webinar. I've been lucky enough to work with these gentlemen for a while and can tell you they are formidable experts on everything they touch, from emerging technologies to global collaborations to, most importantly, finding the best street food when traveling. So hello, gentlemen.
Hello. Hey, Dina. Hello, everybody.
Go ahead, take it away.
Okay, so I'm going to kick off. I am not a domain expert in large language models, so I'm going to start off with just a little bit of background about how we got here. So I'll talk about reasons why you might want to use a large language model. I'll hand things off to Nirav, who will talk about foundational models, and then Mithun will guide us through what generative pre-trained transformers are, what language models are, and then we'll talk about this new project that CyVerse has built underneath Mithun's leadership called Project Chatter, and we'll finish with some demos at the end. Okay, so why talk about large language models? If you go back to December of 2022, there were articles talking about this new chatbot that could answer questions and write essays. And so I have a figure here from Google Trends showing the stratospheric launch of the term ChatGPT and the associated term GPT. And along with those, a couple of weeks later, we start to see this other search term LLM or LLMs. And so these have climbed into the zeitgeist, and they're now part of our daily lexicon, particularly in academia. And when we look at the commercial and private sector, we see companies like Tesla investing billions of dollars in GPU purchases so that they can build language models for their self-driving cars. Companies like Meta or Facebook are spending tens of billions of dollars to acquire GPUs to build their new in-house language models. These 6, 7 companies I have listed over here on the right side are all trillion-dollar companies, and they are all betting their future on AI. A couple of the tools that you may have seen or interacted with in the last 12 months include the relaunch of the Microsoft Edge browser with OpenAI's ChatGPT embedded within it. And this is now called Copilot. And so when you open up an Edge browser, you have the option to open up a chat window, which is essentially powered by ChatGPT. And it can talk to you, and you can use it the same way you would if you were working directly in OpenAI. Google has not been far behind. They launched their Bard chatbot several months ago. Just in the last few weeks, they have renamed this chatbot, and they've come out with a premier version called Gemini, and this Gemini Advanced model, which have equivalent functionality as ChatGPT. And so both of these tools are available to us in our work flow stuff that we have available from the University of Arizona. So this is a screenshot here on the left running an animation of Copilot running in Microsoft 365. And in this example, it's generating a document for the user. You can use this to write emails or to do other things like investigate information or data sets that you have in your Microsoft Online portfolio. This platform is leading the Microsoft stock to become the world's most valuable company. So notice both of these companies are worth over $3 trillion, and they're using these AIs to power their software portfolios. An important caveat though, the Copilot is not free. So if you go to the Microsoft website right now, you can see that it costs $30 per user per month. So really they should call it Microsoft 360 because that's how much it costs per year to use this platform. So it's here, but it's going to cost us money to use for our work. Last fall, I explored using OpenAI's ChatGPT to develop an assistant for a course that I used to teach in the School of Natural Resources around wildland fire. One of the new features that we have in these LLMs is the ability to give it our documents or our data sets, and it will perform something called Retrieval Augmented Generation, or RAG, or just think of it as the term retrieval. And so you can give it your documents. I gave it the components of an entire semester's worth of lectures and readings, and I created what's called an assistant there on the left. And I'm able to ask it questions about the course material. So essentially this becomes a virtual tutor, which is available to our students. OpenAI also has an API-powered platform where I essentially created the same thing using the backend environment. And so we can build our own interface on top of that API to launch our chatbot. We could run this in something like D2L. There is one last problem. The cost for the ChatGPT Pro to get access to the assistants costs on the order of about $21 per month. And so that's an equity problem that we're creating for our students. Students that can afford an extra $20 per month could have access to this tutor to help them in their learning. The other problem is that if we create this API and the university pays for it, we're expecting the cost per interaction to be on the order of 3 to 6 cents, which is not a lot of money until you think about if you have a large multi-lecture course with 50 to 100 students per lecture. We could be encountering costs on the order of $1,000 to $10,000 per class per semester. So that becomes a problem for us. So what we have is an equity problem and an accessibility problem where we can't afford to pay necessarily for things like Copilot or for things like ChatGPT. And I'll pause there and hand things over to Nirav. Nirav, I believe I'm going to keep sharing screen, so if you want to just ask me, I will forward the slides when you're ready.
Thank you, Tyson. So often we hear the term foundational model, but in reality, these are foundation models. And those of you who are not aware of it, I would really encourage you to visit this site at the Ada Lovelace Institute, and they've done an amazing job of explaining how these foundation models come together. Next slide. So when you think of foundation, even though we often call it foundational, is that you take large amounts of data, but you take multimodal data. It's text, it's images, it's speech, structured data, even 3D signals, and then you train something that can be deployed for multiple types of applications. And you can reduce those to things that only do question answering or are very specific on captioning images. But at the core, a lot of these models are capable of doing many, many things, but you tend to keep them very focused so that you get results that are useful. And so the foundational models have an amazing capability, but keeping in mind that none of these things just magically work, you always have to tune them, and I'll talk a little bit more about it. And if you're looking for a very, very good document, the archive link that I have put, this comes from the group at Stanford, the HAI. Please do look at it. I wouldn't even call it a paper. It's like a book. It's 200 or 250 pages, but it's written by some of the leading uh, thought leaders in each of these areas, and it's written without too much marketing hype, because nowadays reading anything about AI is challenging to find a paper that's not over the top or is claiming things that are not very real. So please do check this out. And these slides will be online, so you will have access to the URLs. Next slide. So what are foundation models? So you see sort of on the left, there is data creation where people have created data. And then there is a step of curation, which many of you will be familiar. And then you go through training. Tyson, if you can click, I think I have an animation. Yeah. The real value for most end user comes in at this step of adaptation, where you take some of these large models and then you adapt them to what you need to do, and then you deploy that for your community or for your projects in a way that multiple people can use it. So adaptation is where most of you are going to spend your energy. Next slide. So in the adaptation, there are sort of three big areas. One is task specialization. So if you are segmenting something, or you're taking an image and putting in caption, you will tune it to get better, or you will augment it to get better, or you will do things to make it get better for the class of questions you're working with. And then you have model patching, where you start making the model better, because either it's giving you outright wrong answers, and it's not that the model is bad, the model is learning from what's provided, but a lot of these generative techniques also fill in the gaps, and they fill in the gaps with what they know, and often that means the information is made up or hallucination, and so you have to pass these things to make the model compliant and a correct model. And the last thing, being the most important one, is temporal adoption, because you may have models that have information that's stuck in time because they were built 2 years ago, 3 years ago, and you heard from Tyson that these things are prohibitively large and expensive and take a lot of time and effort. So the ability to pull more recent information is not embedded in the model, but it's an extra step, much like what we are talking to you guys about today, about the RAG step, where you bring in your own data and then you use the model for certain things. Next slide. So what are we doing as University of Arizona, as CyVerse, and as a community to make AI more accessible and democratized? And much like what I was pointing out to you, the adaptation step and the accessibility step, the last two things, like the last mile part, is where the community needs the most assistance, in my opinion, because the earlier steps are handled by very well resourced and large resource companies or organizations. So the first thing is we are making computational capacity accessible. And I have some of my colleagues from Jetstream here. It's an NSF funded project where you will get access to GPUs that are at the cutting edge. And most importantly, they're available at no cost to you. Obviously, somebody's paying for it, but that's NSF. But you can very readily get that for doing your work. And so NSF has the Access portfolio, and we work very closely with Jetstream. We are also reimagining how data management is done when you want to operate at scale, when you want to curate things at scale. We'll have a different webinar on that topic, but we already have been doing a lot in the data management space. But with AI, it changes of how you organize it. How do you bring the data together and train things? The third one is bringing in new AI methods, and I'll show you some real world examples where how do you use tools that can take complexity and make it easy for you to utilize the complex stack with a very easy to use interface, and that's Cacao, which is cloud automation and continuous analysis. And then we are also working with my colleagues at Jetstream to think of inference endpoints. everybody gets excited about LLMs and wanting to use LLMs. But now if you have to call those LLMs, if every person stood up their GPU and said, I'm going to keep this A100 running forever, but I'll only use it once a day, nobody can afford it. And it's criminal to like have a GPU just spinning its wheel. And so what is it that we can create a common pool where there are multiple endpoints and each of you can use it and have allocations for it. So we're going to be working on some of those methods. And then how do we allow novel analysis pipelines? And you'll hear a lot more from Mithun about LLM and RAG. And then the last piece is training for AI fluency. A lot of the hands-on workshops that we are, the new ones that we are planning are around these topics of how do you take LLMs and do certain things with it. And so you'll hear a lot more in the next few weeks. Next slide. This is one of my last slides, and this is the National AI Research Infrastructure. If you have not seen this, please go to this URL, the NAIR pilot allocations, but also look at the last URL, and I apologize. NSF sent this out and it's impossible for anybody to remember. So I put a QR code, and if you want to use that, please do. But I really request all of you to fill that out, especially the ones, those of you who are in education and training. We really need a lot more of this infrastructure kept aside for those activities and not as an afterthought, which typically tends to be when we are doing such projects. Next slide. So now I hand it over to my colleague Mithun Paul.
Yeah, thank you, Nirav. I will start sharing my screen, same slide, but that way I can keep track of the slides, and I will be showing a demo also. But can you guys see the same slide now?
Looks good.
Okay, so I was going to start with the question, what is a large language model? So like Tyson mentioned, this has been a term that completely shook the world in the last 2 or 3 years. And of course, the most common thing that you have known is this, which is the ChatGPT. But like Tyson mentioned, there's much more large language models out there. There is Gemini, there is Mistral, there is Meta that came, there is Llama that came from Meta. All of these work on top of something known as neural networks. You might have heard this term, but more importantly, even if you don't know what a neural network is, I am sure you know what the original neural network is. Yes, your human brain. So this was the original neural network based on which we created the artificial neural network using software components. Now, what do these artificial neural networks do typically? So originally, when it was created, that was at least 5 years ago, the typical task was, hey, here I will give you a picture of a cat and dog. You need to learn what a cat is. You need to learn what a dog is. When I give you a new picture of a cat, you should tell me that is a cat. Those were the initial baby steps that the AI world had done. Now, after that, time passed on, and when this big boom happened in 2021, what OpenAI had done was, instead of simple cat or dog pictures, they said, why not take the whole internet and give it to a very huge, densely packed neural network? And that is how a large language model was born. So as you can see, the entire data from the internet is now fed into a very, very complex model, which goes almost to the size of trillion neurons. But that itself is one of the major problems with these neural networks. This, in the current form, training a large language model is a luxury that only very few can afford, which is why we have only the trillion-dollar industries or companies which have the ability to do it. And the reason is, here is a graph of each of these famous models on the x-axis, and on the y-axis is the sheer amount of parameters, which can be translated into the number of neurons inside these models. Now, these models, as expected, needs huge amount of resources like hardware, time, etc. to train. Not to mention the fact that the more the time it takes, more carbon dioxide emissions it produces. Here's an example. The x-axis is the amount of carbon dioxide emissions that is produced by each of these things on the y-axis. You can see a round trip for a person from New York to San Francisco produces only 900 kilograms of carbon dioxide. A human in his entire life for a year produces only 5,000. US car produces, it's already bad, it has 57,152. But a state-of-the-art large language model, which if you see it mentions only 200 billion parameters, itself is 75,200 carbon dioxide emissions. So not only is this tough for a common man to build and train a large language model, but clearly training this is costing you much more resources, including damage to the planet. So then the first question people asked was, if we do not have the ability to train it, is there a way with which we can take these large language models and use it for our specific task? Remember, these large language models are trained on everything on the internet. Say, for example, you are a researcher who works on rare diseases. And you are the only person on Earth which has a data set on these rare diseases because it's rare. Not to mention, it is very personally identifiable information because of which you have kept it under tight control. But now you are thinking, can we use a large language model to learn what I have, the data set? But of course, you don't want this data to leave your premises. And you of course, do not have the resources to train a huge large language model. That is when people came with the solution, which is known as fine-tuning. The idea of fine-tuning was, initially, we train, or not we, the large language models like Google or Meta or OpenAI trains any of their big models. And in everything under the sun, which is internet, we call that a base large language model. And then you, as a researcher, would give it your domain-specific data set. For example, in this case, your rare diseases data set. And then you run the same training mechanism, but this time not on the whole internet, but on a very specific data. This initially was a great idea and people were excited about it, but slowly they realized that these models are so huge that even fine-tuning them ran into the same set of problems, which is you need huge amount of resources even to load this model, left alone the GPU or CPU cycles needed to train them. So most recently, what people have invented is something known as retrieval augmented generation. And the idea is that when a person asks a question to a chatbot, which is trained on everything on the internet, after the question is asked, we use a retrieval mechanism to go find more details of that specific question. Let me give an example based on what we discussed so far. Let's say you are the same researcher who has your own data, your private data on rare diseases. And when you want to build a chatbot, which your students can use. So when your student asks a question, instead of completely fine-tuning the big pre-trained model provided to you by, let's say, OpenAI, which clearly is not giving anything for free. Let's say you get it from one of the free models like Mistral. You take the Mistral model, and the first thing you do is, instead of fine-tuning it, you use a retrieval mechanism, which simply put is a glorified Google search. Google, if you have not realized, it is just a nice indexing mechanism which quickly replies to your question because they have all these questions or combinations of these questions indexed for you. The same thing, you will take your data, the rare diseases data, index it in a smart way. We call it a vector database. And time when your student asks a question, you first go and retrieve the corresponding chapter from your rare diseases data set. Could be a chapter, could be a paragraph. Now, instead of giving the whole question and asking the LLM to answer from the internet, we wrap the question in this particular page. For example, if the question from the student was, what are the symptoms of a rare disease? I don't know, leukemia, right? And now your model, the retrieval model, first goes and gets you a chapter on leukemia along with the data which only you have, and then rewrites that prompt as, hey, LLM, here is the context, which is, here is the data on rare diseases. Now, based only on this, can you tell us what the answer to this question is? And the LLM, which of course I'm showing a ChatGPT here, but this LLM now is, we are making it focus on just a very small part of the whole data. And people have found out that this is a very nice way to keep the LLM focused. If you remember, this was a point that Nirav was making that has plagued most of the LLM world, including ChatGPT, which is known as hallucination. Hallucination is when the model cannot find the answer, it just makes something up. But by doing retrieval augmented generation, we are able to make the model focus on one small piece of text. Now, having said that, there are still problems for a common man to develop your own solutions based on GPTs and LLMs. First thing is cost. Like Nirav and Tyson mentioned, none of these models or most of the models are in a paid format, where initially, of course, you can chat with the chatbot known as ChatGPT. But the moment you start calling it from a code, your Python code, it's going to slowly start burning a big hole in your pocket. Secondly, the more important point is, if you are a researcher working on personal data, a HIPAA preserving personal data of the patients, you don't want the data to be uploaded to either Google or OpenAI or any of the corporates. Because remember, anything you chat with the ChatGPT, it remembers it and retrains itself on it. So this was one of the primary considerations which people, especially the research world, was pondering upon. Also, the third one is open source versus commercial. As we mentioned earlier, all these commercial products need some amount of payment sooner or later. So can we create an open source model which does all of this for you, along with scalability? Say, for example, you want a model which is sitting inside D2L, which for people who are not from a University of Arizona, D2L is the big framework which caters to each of the student on campus about the courses they learn. So if you want every student to have a chatbot which is trained only on that course data, it runs into a scalability problem immediately. So we have been thinking about all these things, and finally, we were able to come up with the solution which satisfies all these conditions. Ladies and gentlemen, we would like to present before you Chatur, the classroom chatbot, which we call your AI study buddy. What Chatur does is, currently, it is trained on a couple of data sets First one is CyVerse documentation, which of course we are in a CyVerse webinar, so we thought why not start with it. The hardware itself is sitting inside CyVerse. More importantly, it is free. The cost is free because it is freely open for anyone on the University of Arizona premises as of now. Secondly, we ensure that none of the data leaves the University of Arizona premises or virtual network. We were so cautious, we even unplugged our network cable and tried asking the question to the chatbot, and it still retrieved correctly. Third, it is open source. And fourth, this is very scalable, that this can cater to every single student on campus. We are using a lot of what we call elastic hardware, which is smart enough to ramp down and ramp up based on the sheer amount of questions the student asks or sheer amount of users that's logged in at the same time. Coming back to the chatbot, currently it is trained on 4 different documents, starting with the CyVerse documentation. Second is what we call agricultural extension publications, which is a data set which every university has, where usually they publish the latest papers and white papers, especially that come out in the field of agriculture. So this chatbot is trained on that. It is also trained on one course, which we call RNR 335, Introduction to Wildland Fire. This was something Tyson, I think, was teaching earlier or was part of. Then we also gave it the website of Tech Launch Arizona. So granted, this is in a very basic stage where we are testing it over these few hand-picked data sets, but it is doing well. And as you can see, it is a matter of scaling when this can be integrated inside D2L and can be asked to answer questions about a particular course. With that, I would like to show you a quick demo of Chatur. Whoever who has access to CyVerse can now access chaturdev.cyverse.ai. CyVerse.ai. We pull that up here. Click on student view, and let's ask some questions. What is CyVerse?
Miten, would you mind enlarging your screen just a little bit for the recording? Thank you.
This is good?
Yes, thank you.
Okay, so the answer is, I'll quote from the context passage where it mentions, here are some good places to start learning CyVerse. Now, specifically, if you ask questions like, hey, what if I want more data on CyVerse? So this is, like I said, more than the answers. You can start playing with this and start to understand the answers. And here it even gives you a link to the data store manual, which CyVerse is currently trained on. Same thing about the course on wildlife fire. Let's ask which was the largest, when and where was the largest in Arizona. And this is part of the course curriculum, which was in one of the PDFs or PowerPoints that the professor has provided us. And the answer, it says the largest fire in Arizona was Wallow Fire. And also we have recently added something else, which is mkdocs, which if you are not familiar with it, it's a nice markup tool, which helps you create your own nice markup data, and you can give it any of your websites. And that is the whole idea of training it on a random website, which is now it can answer questions on any random website you provide, even outside those in University of Arizona. So with that, I will hand it over back to Nirav. I welcome all of you to try exploring chaturdev.cyverse.ai. Do remember one important thing with AI is that we always need to be very patient with AI. It's just like a little baby trying to learn from each of the questions you're asking. So currently, it is, I want to say, 80% of its full capacity. which is why we are opening it up to people and asking them, let's play with it and tell us what more would you want in terms of precision or in terms of better answers. Nirav, you can take over. Or did you want me to continue sharing?
I don't know if he's there. He's muted.
If you can go to the next slide, that might just be. Oh, you already on.
You have it? Okay.
Are you on the slides?
1 second. Just trying to find that back up. Presentations.
I'll just mention that Mithun went straight to the student view in Chatur. There's also an instructor view where the instructor would be able to create a specific bot for each class and then enroll their students.
Yeah, so this is initially when you log in, you have both the views. We haven't enabled it open to public for obvious reasons, but we have that capability ready. Okay, so now Nirav will talk to you about Jetstream.
Yeah, so next slide. So here is an example, and you're welcome to go to this website. It's danswer.ai, but I've been told it's supposed to be pronounced as dancer, which I think makes more sense. And so here is an open source project which says, hey, you want to do all of these things? It's all available, ready to go. But the moment you try to use something like this, you'll realize there are so many moving parts that come into play. And that's sort of where Jetstream and others and Kakao come together. Next, please. So you can go to Jetstream, apply for an allocation. Limai put some links to it. If you don't know what Jetstream is, please attend it. And then I can assure you getting an allocation, especially for education and training and other things, is really quick. And so you can get access to GPUs, the A100s, to do some of this. If you now want to use Dancer with your own data, you can do that. And so next slide. So here, once you log in, you can see some Edwin's team has already created a template. At the bottom, you can see launch DAnswer, a private open source LLM system. Next, please. And when you click on it, instead of you having to know all the little details of how to do it, it knows that you just choose the size of the GPU, you can choose the model, and you can see there's Llama 2, which is set up by default. Next, please. But if you actually click on it, it has so many models, and keeping one thing in mind that almost on a daily basis, there is some new LLM that's coming out. It's humanly not possible to keep up with it, but there are some really well-known ones. And I also see Gemma, which just came out, I don't know, less than 2 days ago or 3 days ago as open source, and that's already available there. And so you can have access to the models and just say, I want to use this model, but all the work of downloading it, getting it running, is done through the cloud automation capabilities that we have. Another good one that you see on this list is SQL Coder, where you can start asking it to even create SQL for a given database. Next, please. Okay, so that gives you an idea of how easy it is and to use some of this. And I'll take the liberty to actually, Tina, do we have some time or should I end here?
Oh, plenty of time. Another 5 minutes of time before we need to start taking questions. So,
Oh, okay.
Yeah.
Then I will, let me just try one thing here quickly. I will share my screen and show you where did it go? Too many screens. Can you guys see my
yes.
yes. So here you can see it's running on Jetstream. This is running in Indiana. And thank you to Edwin and his team for the magic behind the scenes. And if I go in the admin interface, I can even control creating users. I can create connections to, Slack and, choose different things, but I can create connections. And here are examples of connections. I've connected it to Jetstream documentation, to Learning CyVerse, and to the Data Science Institute website. I even put a PDF from Board of Regents just so that it would do some summarization. But you can go and say add a connector, and you can choose from so many different things. And you can just go here and just add a random website. And I can say I want to pull things from University of Arizona. And I can say, recursives do everything, or just pull one up, or get the sitemap and then just say connect. And it is actually going to now do the job of lining this up, and it'll do the crawling for you. So you don't even have to know a whole lot. It's going to do that heavy lifting for you. But behind the scenes, all the magic that needs to happen, oh, it failed. I maybe there are some reasons for it, but the behind the scenes, all the work is being done for you. And then once it's done, you can come back and say, I want to chat with it. And I can now start asking questions. And the cool part here is when I'm asking the questions, let me just things around. I've never asked this question. Hopefully, it doesn't give me a bad answer. But it'll go through it, it'll gather all the information, and then it'll even present the evidence to you. And then once you take the evidence, you can further drill down into the desired documents and ask more questions specific. So here, see how detailed it gets. And it tells me where it learned it from. And so I can now say, I like the answer. It'll keep track of, all of that. So now you are able to even see what people are giving you as feedback. And so here are the underlying things. And I can say, you know what? I'm going to take 2 of these and ask more questions within those documents. So it's really amazing to see how these things are coming together. And so I just wanted to show it to you guys that it's easy to use, but to set it up is a pretty heavy lift. But we've literally made it transparent for you to do it. And here is like me running it in Jetstream, where I just say new deployment, choose this, next, give it the parameters, choose my model. Usually a medium is a better for task like this. And then, I can just provide certain things and just say launch it. So you can see that this is very accessible, and you don't have to be a super expert to utilize some of these things. So with that, I will stop sharing. Okay, so we just have the conclusion, right, Tina? Or Tyson, do we have any more slides? Sorry, I jumped.
No,
in.
we're good to go, I think. So we want to open it up for questions.
Yes, please feel free to unmute yourself and ask questions. I didn't see any in the chat. Nothing in particular.
Yeah, and raise a hand if it gets busy.
Yeah.
All right.
No questions?
Okay.
Okay.
Oh,
Oh,
there's a question from
Go ahead,
Brian.
Brian.
yeah. Brian, you're still muted. Feel free to unmute and ask.
Won't let him unmute. Let's see. Is there a way we can, Tina, you as an administrator can unmute him by any chance?
Brian's
Brian,
asking,
yeah,
can we index government pages?
I would think anything that's on the internet could probably be indexed.
So yeah, so Brian, for most things, given that there are some permission issues that you want to honor from an organizational perspective, but as Tyson was saying, if it's a government document repository or a site, then you have the permission in most cases to go crawl it like what I was showing you. But keep in mind that a lot of these things, the first cut will always be disappointing, I can guarantee you. But then you have to tune certain things to make it more meaningful. And by that, what I mean is the secret sauce in a lot of these things is how the embedding is done, how the vector store is organized. Once you understand that for the class of documents, then you want to crawl everything that they have, and then that will give you good results. But short answer, yes.
Yeah, I would add along the government line. So Cacao is cloud agnostic. It's running on Jetstream2. If we were to take a Cacao template, we could run it in Amazon on an AWS Gov Cloud behind the firewall where the Forest Service data are or their websites are. And then we could probably index them that way. So any of these open source models, you can run them typically using containers or some other orchestration tools.
But yeah, Brian, short answer, absolutely, and it's definitely doable. One thing that we didn't cover, and I sort of missed on that part, the teams that we had created, we had a separate group when we were doing our little code fest on just quality control and question answer assessment, because it's very easy as a human being to say, oh, this thing works and it's awesome, but it is not working to its full potential if you don't test it. And so anytime you're doing some of these things, building your test suite and then verifying that this can do what it's claiming it can do, and the answers are acceptable to you and your users. And so if you're doing that, please make sure you are. So Carlos.
Carlos has asked a question. What is the timeline on Chatur or future development?
I would say in the next month and a half, we are going to be on a listening tour with our colleagues and departments that are already asking us, and then put together a phase two. Because the first part, Carlos, as you are aware, was a very quick 3-day activity, which then followed with some polishing. We would convert this into more of an engineering exercise where we say, this is what we need to build because it's not commercially available. We can't do this, we can't do that. And then take the reflections of things the departments and the students want and put something together. So I would say in a month, we'll know what we are doing, but we would start working on it in the next 2 months with the hope of producing something in the next 6 months.
Are there any more questions for the team? Okay.
And given we have a little bit of an Arizona leaning audience, we also have this running in our HIPAA environment. So if you want some parts where you're working with medical records or health records, we are able to do that as well. We cannot do those things on Jetstream side as yet because of the legal components to how we handle HIPAA data on campus.
Very good. Okay, thank you everyone for joining. Please make sure that you join us for our next webinar, Friday, March 22nd at 10 a.m. Shravan Aras will show us how to use sensor fabric to make working with wearables data easier. So please join us for the next webinar, and thank you everyone for attending. We'll, like I said, post the video recording up on the CyVerse YouTube channel later on today, probably. Bye now. Thank you.
Bye.
Thank you, gentlemen.